So just because we're changing log base doesn't mean our rules don't apply. Of course, we know that if we have multiplication, we can split it into addition, and the same thing holds true for division. If we have a division problem, we can still turn it into subtraction, and the only difference is that it won't say natural log, it'll say whatever log base we're working in. And of course the power rule still holds. And so one thing I want to remember is that if I said this is nothing more than a y equals, and I decide that for today I don't like the word log because it makes me break out in hives, then I could in fact turn that into exponential form. So there's my base, there's the exponent, there's the answer. And so what I notice is, oh, usually I'm looking at something like this. Hey, wait a second. What did I just do? Oh, I switched the y and the x. What is it called when I do that? You are so right. So this would be the inverse of what I started out with, and we'll call it g of x instead of y. It means the same thing. So just remembering that those two are in fact inverses of each other. Okay, so now looking at the properties of inverses, remember this means if and only if. And of course, if I take either side and I decide that I want to convert them, I can turn them into the other form. So this is just just managing to rewrite. These are rewrites of each other. They both mean exactly the same thing. This version's a little easier to tell that with, because of course if I put it back in exponential form, oh, there's the base, here's the exponent, and then this is the answer, and voila, I have what's on the other side. Second rule, this is my rule of, I'm calling this the Torres rule of disappearing. Just like natural log and the e base cancel each other out, same thing happens here. If the exponential base and the log base are the same, then all of this stuff undoes each other, and it just leaves x all by itself. And same thing is true if I have it written this way. So if the log base and the exponent base, exponential base, are the same, then all of this cancels out and I just get whatever the exponent is. I could think about that also as, remember, when I have an exponent on a log, I'm allowed to bring it down, and so it would look like x and then log base a of a. And of course this is always, the reason it cancels out is because it's equal to 1. And so x times 1 equals x. So simple. Whoopsies. This is what happens when I'm talking and writing at the same time. So rule 2, all the x's have to be positive because I can't take log of a negative number. And remember, that's what I was doing over here to start with. And on the bottom one, that works for everything because exponents certainly can be positive or negative.